Okay, in this fourth problem, we have a board that's hanging off a table, and if the board is 1 meter long, then the midpoint of the board, of course, is at its midpoint. So if 40 centimeters is on the table, then that means the distance to the midpoint, we'll put the midpoint over here so it looks a little prettier, that clearly has to be 10. And so that's going to pull down and give me a little bit of a torque there. Again, this would be my pivot point. So if this 1 kilogram mass is 20 centimeters in from the end, then that means it's also 20 centimeters in from the pivot point. If the 2 kilogram mass here is only 10 centimeters in from the end, then that means it's a total of 30 centimeters in from that. So I'm going to have the 2 kilogram mass is 30 centimeters from the pivot point, and the 1 kilogram mass is 20 centimeters from the pivot point, and both of those are trying to torque me counterclockwise. The mass of the board, of course, was 0.8 kilograms, and it was, we said, 10 centimeters over on the clockwise side. And then we're going to stick a 4 kilogram mass out here, and we're going to say, well, how far out can we push it before these two clockwise torques would balance out the counterclockwise torque. And so now it's just a matter of solving for x. So 2 times 30 is 60, time plus 20 clearly is 80, and that's going to be 0.8 times 10, which would be 8, plus 4x. So I'm going to have to subtract 8 from the other side, and that would give me 72 equals 4x. So then I divide both sides by 4, and 72 divided by 4 gives me 18. So 18 centimeters over from the pivot point would be where that weight is. So if we're measuring from the beginning of the board going over, that would be 40 plus 18. So that would be 58 centimeters this way from the edge of the board. And that's all you got to do for that one. Super simple. You'll love that one.